Everyone to this backend FastAPI workshop. Firstly, let me introduce myself. My name is Pinal Sakar. Okay, I have been working in IT and I was also training many students here in 10,000 coders. I started my career at TCS as a developer and slowly I transitioned into training because I liked the training part more than developing. And I have about 5 to 5.5 years of experience in total in both IT and teaching as well. And today we will be jumping on to building a backend in Python using FastAPI. Okay, and this will be an AI-powered backend, which means instead of we are not just building a FastAPI backend here, we are also integrating an AI feature as well, and we'll talk more about it, like what that feature is and all. And everything that we do in this workshop, you will at the end of the workshop, you will also get a GitHub repository link. So if you guys want to, you can just open that repository and access your code in that repo as well. Just for a reference, I have that link already shared here in my screen, but you guys can later access it after the workshop as well. Okay. Yeah. So with this, let's just dive straight into the workshop. So coming to this workshop, as we discussed, we'll be building a project which will be based on AI and also FastAPI. Okay. Let's just first understand what this project is. Okay. So the project that we'll be building in this workshop is goal-based AI generated tasks. So basically, what this means is in this project, we will be generating tasks based on a like vague code. Okay. So as we see here in this slide, this is like turning vague goals into an actionable task. For example, let's say I have given a goal called Learn Fast API. Now, what this Fast API workshop, Fast API backend will do is it will take this goal, send it to an AI model that will be integrating into this project as well, which will be using LangChain and Hugging Face models. We'll see the architecture, but for now, let's just understand what this project is doing. Okay. So basically, we will be giving a goal to this backend API, and this backend API will forward this goal to an AI model, and this AI model will generate 5 tasks based on our goal. So whatever goal we are giving, basically your AI model is giving you 5 tasks that you can do to achieve that goal. Okay. Now, what happens here is instead of just getting the task and all, we will be also implementing databases in this. To be precise, we'll be using SQLite database to store our tasks that are being generated by an AI model. Okay. Yeah. So in this project, we'll be building our API. We'll be building our backend API using Fast API. Okay, and our AI model will be Mistral. Again, this is a model that we have readily available in Hugging Face. If you are new to these terminologies, just don't worry about it. As we discussed, we will be in this workshop. We'll be going in detail about what all of these are. Okay. For now, I'm just giving you an overview of what we'll be doing in this. Then slowly we'll be moving on to what everything does and how do we build it. Okay. Hi, Akila. So thank you. Welcome to this workshop. Again, as I discussed, if you have any questions or anything, just ping in chat. Briefly, I'll keep checking the chat. Okay. If you have any questions. So yeah, coming to this project, we'll be using SQLite for database, and API will be building it using FastAPI. Again, if you are new to all these terminologies, we'll be going into detail. And for an AI model, we will be using Mistral. for our AI, and then we'll be using LangChain for integration for our AI integration. Okay. Now, before we jump on to code, like how to build this, to jump on to APIs, first thing we need to do is we need to understand like communicate with a backend, right? What is a backend and how does any application communicate with our backend? Now, to quickly like demonstrate this, I'll take up of my slide here. Yeah, coming to again like technology stack, we'll be using FastAPI. Pydantic is for validating our data. So whatever data we have to validate it to check the data types, for example. When you are creating tables in databases, you use the data types to validate, right? So that validation is being done using Pydantic here. And then we have SQLAlchemy, which is our ORM. We'll again go into detail like what is ORM and all. This is basically what we are using to build our database. SQLite is our database, and then we are having LangChain, which is we will be using to communicate with our AI models. And we are getting our AI model from Hugging Face here. And this is our AI model that we'll be using to generate our task, okay, which is Mistral 7B. Now, before we jump on to like what is fast API and all, we need to understand what exactly do we mean by communicating with backend, getting data from backend. Right? What is backend and how does it work? So for this, what I'll do is I'll simply demonstrate to you. Like I'll simply show you like what everything, how everything works. Let's say this is our client system. Now, when I say a client system can be anything. It can be a laptop, it can be a browser, right? Or it can be your mobile. Now, a client system can be anything. It can be either a device, or it can be a browser, or it can be and also another server trying to communicate with your backend. Okay. So a client system, what it is currently trying to communicate with your backend, is currently trying to communicate with your backend, and it is asking for task based on a goal. So here, what we are doing is from our client system, we are sending a request to our backend, and along with that request, we are sending a vague goal. Okay, we are sending a goal. Now, what server is doing here is server, which is our backend. So our backend consists of server and also database. Right. So in our backend, we have two parts here: a server and also a database. Now, for our project, we will be using SQLite. So SQLite will be our database. Okay. So from front end, we are sending a goal as a request, and that is going to our server. Now, server, what it is doing is instead of trying to directly create task here based on our goal, it is again sending the same request to our AI model. Now, here we are getting Hugging Face into picture. Now, this request that is going from our server to our AI model, which is currently we are using Mistral, right? So this request is being sent using Hugging Face router. Okay. So Hugging Face router is currently sending this request from our server to our AI model. And to implement this entire thing, we'll be using LangChain. Again, I'll go into detail what is LangChain and what is everything. For now, I'm just explaining you our flow. Okay. So when I say we are trying to get some task from our backend, this is how our backend looks like. So in our backend, we have several components again. We have a server that will be building using FastAPI. So we'll be building our backend using FastAPI, right? And then we have a database as well in which we are storing our task. Not just storing, we are doing many things there. We'll be going into detail. So we have our database. In this database, we are storing all of our tasks. And to get those tasks, we are using an AI model. and those tasks are being sent from our server, backend server here, to our AI model using Hugging Face router. LangChain. This is how we our backend database. We are using SQLite, and to build this, we are using SQLAlchemy. We're using SQLAlchemy, which is a frame library in Python, which is an ORM. Again, I'll explain what is an ORM, and then we have Hugging Face, we have LangChain, and we have our model, which is Mistral. So this is how basic our basic architecture looks like. Okay, in our project. Now, going back to our data flow. So now that we understand how we are sending a request to backend and how backend is sending a response and how it is communicating with our AI model here, let's understand the data flow. So here what we do first is from our client layer, it can be a laptop or a browser or anything. We are sending a request to our API layer, which is our fast API. We are sending a request to our backend here, right? And from FastAPI, we are again validating our data using Pydantic. As we discussed, Pydantic is basically a library that we use to validate our data types. So whatever data that we get from user, whatever data that we are sending back to our user. So from here, whatever data that we are getting from user, client system, and whatever data that we are sending back to, we are sending back from here. Now, we cannot just send random data, right? There has to be a structure that we follow. There has to be a proper data type that we follow. Because whenever you are building your backend, you are using databases here, and database understands only table format. The database needs to like store. If you are building a table, you need to have data type specific to each every column. Now, instead of sending those data types, if your front end is sending, let's say, for example, you have a column which is title for our task. Okay. Now this title column accepts only string str. Now instead of sending a string as a title, what if our front end is sending numbers 1, 2, 3, 4, 5? This is a problem, right? Because we cannot store numbers inside our database here. Inside our database layer, right? Because database has strict validations where every column will accept only one type of data type. So to avoid these kind of issues, okay, we use Pydantic. We use Pydantic to avoid these kind of issues. Now, what Pydantic does is we have schemas that we use in Pydantic. In Pydantic, we use something called as a Pydantic schemas. Okay, these schemas are basically blueprint of your data, because these schemas are basically a blueprint of your data. Like how we create classes, and based on classes we create objects, right? Similarly, these pydantic schemas define our blueprint of our data. So in our data, what are the fields that we're expecting? So in our data, what are the variables that we are expecting, and also what will be their data types? All of these are defined inside a pydantic schema, and based on our schema we will validate. So whatever input we are receiving from user, if title has string or not, if it does not have string, we will not accept that input. Okay, so that kind of validation is done using pydantic here. Now after we have done with your validation, our request directly goes to our AI model, and that is being handled by LangChain and Hugging Face router. And after we are done with our processing, after AI has taken our goal and sent us back some 5 tasks, we directly store those tasks into our database, which will be SQLite. Okay. Now, with this, what we'll do is we'll first let's understand what is FastAPI. So, since we now know like what does the architecture look like, and what does our data flow look like, we'll try to understand what each of these components are. What is FastAPI, Pydantic? What are each of these components? And then we'll move on to actually building our project. Okay. Now, coming to FastAPI, what is FastAPI? Main the main title of this workshop is building backend using FastAPI, right? So when we say FastAPI, what exactly is FastAPI? Now, FastAPI is a modern Python framework that is used to build efficient and fast backend. Okay. And again, when I'm saying it is used to build efficient and fast backend, this can be used. This can include our server, our database layer, and also our AI integration layer. Okay. To build all of this, we are using FastAPI. It's basically a framework that we have in Python, modern framework that we have in Python, which is used to build backend. And this backend has web APIs. Okay. Now, since we know what is FastAPI and why do we use it, we have to understand what is an API. We all already know that API is called as a application. Akila, I didn't understand you. What do you mean by can you make it down?
Sir, I'm asking about Notepad. Just once you scroll it down, I just want to see what you have written from the starting because I entered in the middle of the session, right?
We don't have anything, Akila, in this. We are just simply we have to simply noted down like what are the technologies that we'll be using. Again, everything is in this slide as well. Okay. Basically, we have noted down what are the technologies that we'll be using, which is FastAPI, Pydantic, SQLAlchemy, SQLite, LangChain, and Hugging Face. And this is our AI model, basically. Okay. Uh, Let me just zoom out so you can see it. Yeah. So coming to like what is an API? Now we already know that API stands for application programming interface. Right. The keyword here is interface. When we are saying API stands for application programming interface, interface means it is providing an interface to communicate between our backend and client systems. Now, the reason why I've said here client systems is because these can be anything. It can be a browser, a device, or it can be another server as well. Okay. So, an API is basically an interface that we use to communicate from between our backend and client systems. Now, here another important thing to understand is what is a REST API. Okay. Now, REST API stands for representational state transfer. Basically, what you need to understand here is that in REST API, all the data is shared in form of JSON. Now, what is JSON? JSON is basically, simply put, it is an array or a list of objects. By objects, I mean in Python, we call them as dictionaries. Okay. So a REST API basically deals with data which is in this format, an array of or a list of multiple dictionaries or objects. Okay. Now, one problem that we have here is, yeah, one problem that we have here in this project is that we are having a database which is SQL. Now, SQLite also stores everything in form of tables. Now, in SQL, we store everything in form of tables, right? Which are rows and columns, which have columns and rows. Now, but Python understands only data types, which are objects. Okay. So here, the main thing is that database understands only tables and columns. So SQL communicates using queries, right? But in Python, we cannot directly write queries. In Python, we cannot directly execute queries, right? And also, Python does not understand tables. Python understands only objects here. So, how do we communicate between these two? This is where SQL alchemy comes in. Okay, SQL alchemy is an ORM. Now, ORM stands for object relational mapper. Now, what I mean by object relational mapper is basically take it like ORM is a bridge between your Python and SQL. So SQL Alchemy is a bridge between Python and SQL. Okay. So basically here we have Python that understands only objects, and we have SQL that understands only tables. Now, what SQL Alchemy does is it acts like a bridge in between these two. So it is basically converting our it is basically converting our data which is in table format into object format for Python to understand, and also opposite. So what SQL Alchemy provides you is it provides you some methods, simple functions that you can use to perform database operations. Now we already know what are database operations, right? We have CRUD operations, which are create, update, read, update, and delete. Now for all of these operations, generally in SQL we write queries, right? Whereas coming to SQL Alchemy, it simply provides us simple Python functions that we can use to perform all these kinds of operations. Okay, and also SQL Alchemy automatically converts your data from table format to object format, so that Python can better understand. So it acts like a translator basically. It acts like a translator which translates data from table format to object format, which is why it is called as an object relational mapper, where it is taking the object understanding of Python and also the relational databases that we have, which is SQL, and it is mapping both of them. Okay. Yeah. So now that we understand what is FastAPI and what is SQL Alchemy, we'll start by building a simple application. Okay, we'll start by building a simple FastAPI server. Now, before we jump onto that, first we need to know what are the things that we need to do to basically get started. So, how do we set up our project, right? For this workshop, we'll be using VS Code. Again, you can use any tool here, any IDE here, any code editor that you are comfortable with. We can also use PyCharm if you are like into that. For this workshop, we'll be using VS Code. Okay. Now, first thing you need to do is create a project folder. So for that, I'll go to folders, create folder, and then let me create a folder here and call it workshop project. Okay. Now, once you have created your project folder, first thing you do in any Python project is create a environment. Now you might keep saying that create a virtual environment, do all of your projects for all of your Python projects, create a virtual environment. Now, what do we mean by virtual environment? Now we keep saying that create a virtual environment, but what is virtual environment? Right? Now, a virtual environment simply put is a copy of all your Python libraries, and it is not just a copy, it is a local copy of all your Python libraries. What I mean by this is it basically acts like a copy of your Python libraries, and here I am saying it is local, which means in whichever folder you are creating that virtual environment, whatever libraries you are installing right now are belonging only to that folder. Basically, what we are doing here is divide segmentation. Okay. Now, instead of installing all of our packages and libraries that we'll be needing for this workshop, we'll be installing them into our folder only. So whatever folder we have created here, we will be installing all of them into only this folder. And for another project, we will be creating one more virtual environment, and that acts like a its own local copy. Okay. And this is being done basically to separate all of our projects so that no two projects are mixing together. This is basically used to avoid dependency issues when it comes to projects. Okay. So now let's create a virtual environment. For that, we'll open terminal, and in terminal, to create a virtual environment in Python, the command for is Python dash m venv, and then here we are giving our name of our virtual environment, name of the environment that we'll be using. I'll simply call it env. Okay. And here dash m means we are using module, we are using a module. Which module? Virtual environment module, venv module. So using venv module, we are creating a environment, virtual environment. Click on enter, and slowly if you observe here, Python will create a virtual environment for you with the name of env. Let's just wait a second for this to finish. Meanwhile, do you have any questions? No? Fine. Yeah. Server virtual environment got created. And here, if you observe, you have several folders like include, library, and scripts. Right? This library folder will basically include all of the libraries that we will be installing for this project. We will jump on to what libraries to use, but for now, we are just setting up our project environment setup. Okay. Now, once we have created our virtual environment, we have to activate it. For activation, the command will be the name of your virtual environment. So, whatever folder that name you gave, environment name you gave, that name, env slash scripts slash activate. What you're basically doing here is you're going into this environment folder, and then you are going on to scripts folder, and then you are executing this particular file. You click on enter. Now, if you observe in VS Code in terminal, you have currently activated your virtual environment. And this is the indication for a virtual environment where you will get the name of your environment here. Okay. Now, coming to the libraries that we'll be using for this project, those libraries are Uh, okay. So the libraries that we'll be using for this project will be, first things first, since it's a fast API project, we need to install fast API. So fast API. And for validation, data validation, we'll be using Pydantic, right? And as we discussed, we are using SQLAlchemy for, which is our ORM, which is basically translating our database in table from table format to object format, right? And then we'll also have to install LangChain, which we are using to communicate with our AI models. And we also need to install LangChain OpenAI. I'll explain to you why do we need LangChain OpenAI, and then finally we'll be needing Python dot env. Okay. Now in this, we'll be using one more library, which will be UVCon. Now, what is UVCon? UVCon is basically something we are using to run our server. Okay. You consider this basically like your Python, like how we have Python interpreter to run your Python code. We will be using UVCon to run our server. Okay. Because the server has to be persistent, right? A server has to be constantly running. So for that, we will be using UVCon. It is basically running your server. And yeah, for now, these will be the libraries that we'll be using. And for installing these, the command will be, we'll be using pip for installing all these libraries. So we'll say pip install FastAPI, UVCon, SQLAlchemy, LangChain, Pydantic, LangChain OpenAI, and Python dot env. These are the libraries that we'll be using for this workshop. Now, while this is getting installed, again, let's come back to here. If you guys have any questions while those libraries are getting installed, just let me know. And those who have joined just now, we'll be building a goal-based task generation project where our simple agenda is. So we'll be sending a goal to our AI model, and that AI model has to give us 5 tasks to achieve that goal. Okay. So this is our agenda basically. So we will be sending a goal to our AI model, and that AI model should generate 5 tasks based on our goal. And for our implementing all of these, we will be using Fast API, and also for saving these tasks, we will be using a database which will be SQLite. Now, since this is a this we are using many libraries here, it takes some time to install. Again, this depends on your internet connection as well. If you have already installed these libraries before, Python does a very clever thing here, where instead of downloading them again, if you observe here in some steps, it is using cached, using cached. So what it's doing is basically, since I have already all these libraries already installed for other projects, it is using those files for adding them to our project here. Okay, instead of downloading them again and again, it is basically using the existing libraries that we have already installed in our system. So yeah, done. So we have installed all the libraries. Now what we'll do is we'll create our project structure, and then we'll write our first fast API application. Okay. Now, first thing I'll do is here is create a folder called app. So I'm inside this app folder. We will be having all of our files that we'll be creating, Python files that we'll be creating for different purposes. Okay. First, I create a file called main.py. Now, this main.py file is our gateway. So, whatever the request that we're getting from client will first come onto this file, and from this file it will go on to other places. Okay. Now, let's start with creating our very first FastAPI application. Okay. Now, for that, first thing we have to do is import our FastAPI library. So we just installed our FastAPI library, right? For importing it, we'll say from FastAPI import FastAPI. Now, if you observe here, Python is not automatically giving us it is not giving us hints. That is because we still don't have any environment set up here. So let's select our virtual environment. Let's also try to run this now. After importing our FastAPI library, the next step will be to start our application, to create our application. For that, we'll say app equal to FastAPI. Okay. Basically, what we are doing here is we are importing our FastAPI application, and here we are initializing that application. We are starting that application. We are creating that application here using this line of code. Okay. Now, before we move on further, we have to understand how does sending a request and how does a request look like. So until now, we kept saying that from front end libraries or from front end client systems, we are getting a request, right? And the backend is handling all that request. So we have to now understand what does a request look like and what does the request contain. In a request, we have several components. We'll look into all those in detail. Okay. Now, when I say a client's system is sending a request, okay, to our backend server, it is sending a request to our backend server. This is our client. Okay. Basically, our client is trying to access our backend, and our backend server has an URL that it is automatically running. Okay, our backend is automatically running in a URL. When you are running a FastAPI application, but UVCon automatically creates a URL in which your server will be running, and you will be able to access the server using this URL. Okay. Now I'll take example of Amazon here. Let me open Amazon.in. Now, when I open Amazon.in, if you observe here the URL, I'm saying Amazon.in, and I'm getting this page, right? Now, if I click on any other product here, for example, let's go to, let's say I'm trying to sign in now, right now. Now, when I click on sign in, if you observe the URL here, Amazon.in was common. So Amazon.in we used, this URL we used to basically access our Amazon website, right? Similarly, in our backend FastAPI backend, you will be having a URL that FastAPI automatically generates, and using that URL, you will be able to access FastAPI backend, right? On top of it, we have a path here. Now, what is this? What do I mean by a path? So whatever pages you have or whatever like features you have inside your backend, everything can be accessed using a path. Okay, we call them as URL paths. URL paths. This is basically like how you have Google Drive. So inside your Google Drive, you have many files, right? And every file will have its own URL. Every file will have its own URL. URL one, URL two, right? Now, how these are basically like an address for whatever file you have inside your Google Drive. Similarly, for whatever actions that you have, for whatever tasks that you are trying to do, which can be creating a task or updating a task, existing task. So we discussed about CRUD operations, right? So all those different kinds of operations, we will be creating different kinds of paths that we will be exposing to our backend, and which can be accessed using those kind of paths. So for example, let's say my backend path currently is localhost 5000. Okay, I can have a path which can be localhost 5000 slash task slash task. Now this task is our path here. This part is our path here. So we are having a unique path to access something, and this can be a path for accessing all tasks. So this can be a path for accessing all of our tasks. Okay. Similarly, we can have one more unique path, which can be slash. For example, our this unique path is slash update task. So we can use this path for updating our task. Similarly, we can have different paths that we can define for doing different kinds of operations for all of these uh, operations that you're trying to do in your backend. Okay. Now, in FastAPI, what we do is basically we start with our creating our FastAPI application. Okay, and then we define different paths for doing different operations. So for example, let's say I'm simply trying to first open my FastAPI app, URL into my browser and just check if my API is running or not. For that, here I'll create a path, and that can be done using app.get. First, I'm writing my code here, and then I'll explain to you each and every line. So what each and every line is doing. Okay. So I'll say app.get, and here I will define a function which can be, let's say, sanity. And here, after in app.get, here we are defining our path. Let's simply give a slash here. Inside this function, I'm saying return. Again, I'll explain to you what every line is doing here. First, let's just write our code. I'll say return message API is running. Okay. Now let's understand what is happening here. Now, you guys are familiar with the concept of decorators in Python, right? Now, to create a decorator, we use at the rate. If you guys remember, in Python, to create a decorator, we are using at the rate. Now, what FastAPI does is FastAPI provides you different decorators for all the operations that you can do in a API. For example, when I'm talking about CRUD operations, right? Yeah. So when I'm talking about CRUD operations here, CRUD, okay? When you are trying to do these operations using an API, in API again we have different kinds of operations for all of these. So coming to an API, we have operations like get, and these are the different kinds of requests that we'll be sending to API to perform different kinds of operations. We have get, we have post, we have put, we have delete. Okay, and get can be for read. So for reading our data, for a read operation, we can use get. For creating, for creation in the sense, we are sending a task to our backend from our client. We are sending a task to our backend, right? And in backend, we are receiving that task and creating our task. For that, we will be using post request, and put can be used to update our task. This is for creation, and then delete is for deleting our task. Okay, so our application will have all these different types of operations. Okay, so we have create task, we have get task to get all the tasks, and then we have put to update our existing task, and then we have delete, which will delete our task. Again, all of this is currently being also stored in our database. So we are not just simply creating our task and forgetting about it. We are also using databases to store all of these tasks that are being generated by our AI, which is Mistral. Okay. Now going back to creating our first fast API application. So we are saying in Python, we are asking fast API. Yeah. So we are asking fast API here. Take my function, which I'm saying sanity. I'm calling it sanity. Okay. So what fast API is doing here is it is taking a decorator which is get, and to that decorator we are passing our sanity function. Now what fast API does here is it takes our sanity function and it attaches it with our get request for API. It is taking our function, attaching it to get request. So whenever we are having this get request from our client, so let's say client is currently trying to access our API, currently trying to access our fast API application. Okay, if we have a slash in the paths, so you remember right? When we talked about path, we talked about all of these different kinds of paths, right? We can have a single slash or slash task or slash update task for whatever paths it can be. For all of these paths, we are creating different functions here. So when someone is trying to access this path, this function gets executed. And what is happening inside this function? We are simply returning some message here. So when I run this FastAPI application and try to open this URL with a path of single slash, so I'll say localhost 5000 slash, I should get this message as a response because from my function I'm sending that response message as a return here, right? So let's run this application again. For running this application, we will be using ubicon. Ubicon is used to run our server. The command for running our server using ubicon is ubicon app.main colon app slash dash reload. Now we are doing here is we are telling Python go into our app folder which we have created here. Inside our app folder we have main file main.py, and from that run this app function. We are this app application, fast API application, which is named as app. So it is going there and running that. And since we are saying dash dash reload, what it basically does is whenever you have any changes in your file, it automatically runs that server again. Let's run this and see what happens. So now you are getting a message here saying that Ubicon is running on this link. And when we open this link in browser, yes, I get post, put and delete. And when we are opening that link in browser, you can observe here, whatever message that we were sending from our function, right? We said return off this message. Same message we are getting here as an output. So what is happening here is basically we are trying to access this path, and this path is currently attached to this function. And whatever we are doing in this function is coming as an output here. From our function, we are sending this message as an output in return, right? So this is how a simple fast API. This is how simple it is to build a API using fast API. All you have to do is get whatever method you are trying to use. If you are using get or post or whatever, create a decorator. You say app, which is our fast API application, dot get, which is our request method, and then we attach our path. And to this, now we are passing this function. This function runs whenever someone tries to access this path. Now, before we jump on to like creating all the other paths, so in our Python, in our application, in our project, we'll be doing many things, right? We will be having different kinds of paths. So let's define all the paths here first, and then we'll move on to building our application. So we'll have a slash for a sanity check, just to check if the application is running or not, and then we have a slash tasks for getting all tasks. Okay, we'll have slash task and slash id. Now, this path is to get a single task based on task id. Okay, and then we'll have another path to update. So we'll say update, and this will be for put request, which is for update existing task. And then we'll be having delete, which is basically to delete a task. Okay, before we start defining all these paths, so we already have defined this path, right? Before we start defining all these paths, first let's like establish our database. First, let's create our database. Okay, configure it. So for that, I'll create one more file in my app folder here, and I'll call it database.py. Okay, now in this, since we are using SQLAlchemy to as an ORM to like act like a bridge between our database table and our Python, which understands objects, right? We'll be importing that module here. So we'll say from SQLAlchemy import create engine. I'll explain again what these are, what is create engine, and why am I importing all these libraries. We also need to import SQLAlchemy.orm import session maker, and then we also need SQLAlchemy dot ext dot declarative, and from this we need to import declarative base. Now let's see what are these. Coming to engine, engine is the component that handles our database operations. Think of it like your Python interpreter. Okay, so an engine is the component that is actually doing executing all of your database operations. Okay, coming to a session, for each request coming from client, we create a separate session. So for each request that is coming from client, we are creating a separate session. And the reason we create a session is for a better control over our database. So whatever operations that are being performed in that particular session, at the end we will be committing those operations. We will say database commit, and then we will close our database. Okay. So for fine control, we are using sessions here, and then we are using declarative base to act like a base model for our database. Now, you have come on to a new terminology which is called as a base model. I'm saying base model. We use declarative base to create a base model. Now, what do I mean by a model? Right? We need to now understand what do I mean by a model. Okay. Now, since we have already established that SQLAlchemy acts like an ORM, right? So basically, we are using SQLAlchemy to create our database, right? Now, SQLAlchemy understands only objects, right? So to create our database, first, what do we do when we are creating our database? We define our table, right? We define our table, we give our table name, and then we provide columns. So all the columns, and inside that columns we provide the name of the column and also prototype, right? So whenever we are creating a table, we define our table name, we define all the columns that we need, and for each and every column we are also giving the name and the data type of that column. Coming to ORMs, a model is the structure of a table. Basically in SQL, whenever you are creating a table, And when you are defining your structure there inside your SQL query, so you say create table name, and then here you define your columns, right? You define your column, and then you define your uh, data types here, right? Similarly, we create a model, and inside this model, we define our table name, we define all the columns and the data types as well. And this we do using a class. We do basically do using a base class, and that base class is provided using declarative base. Okay, so let's write our database configuration code here. So first, I'll say uh, database URL is equal to SQLite. Since we are using SQLite database here, we are basically mentioning SQLAlchemy to create a database using SQLite, and here we are providing the path of our database file. Okay, again, SQLite is a database manager which stores everything in table format only. So SQLite is also it is a file based database management system. Okay, where it is also storing everything in table format. Again, all of our data is being stored in table format only, but the difference here is that all of the data is stored in a single file, and in SQLite we do all the operations based on that single file. Now here we are telling SQLAlchemy I'm using SQLite, and on top of it here I'm providing the path. So I'll say name of my database file will be task.db. Okay, and next step will be to create our engine. So we'll say engine is equal to create engine, and here we need to provide some parameters here. First thing we do is we provide our database URL which we just created. So we say database URL comma connection arguments. So what we are doing here is we are creating our database engine. So the component that is handling our database operations, we are creating that component currently. This is our Python interpreter. This is our interpreter that is running our database commands. Okay, and to this we are passing our URL and telling that I'm using SQLite for this particular database, and the name of the database is task.db. Now here we need to provide one more default argument that we need to provide, which is, and when we say connect tags, basically I'm telling that for this connection for creating this database engine, use these arguments, and that will be check same thread is should be false. What I mean here is whatever database sessions that I'm running currently, for all those sessions, don't use a single thread. I'm telling SQLAlchemy here to use multiple threads so that we can handle multiple connections simultaneously. Okay, and then we say after this we say session. So now we are creating our session. We have created our engine. Now we are creating our session. So session local is equal to session maker. We will use session maker that we imported here from SQLAlchemy. Session maker. Here we are passing a few things. We should be auto flush is false, and then auto commit is also false. I'm telling SQLAlchemy here, don't auto commit all my transactions. Commit only if I specifically mention to commit. Okay, auto commit will be false, and then I am binding to my engine here. Whatever engine that I have created here, I'm passing this engine to my session. So whenever a session gets created, automatically this engine also goes attached to along with that session. So for that, I'll say bind is equal to engine. I'm passing my engine here, which I created. Okay. And then next step will be to create our base model. So as we discussed, we are having a model is basically something that is defining our table structure. To create that model, we first import a base model, and on top of that base model, we are creating our model. On top of that class, we are creating our model. We are using a base class to create our model. For that, we are using declarative base. So in this line, I'll say base is equal to declarative base. So whatever base model that SQLAlchemy is providing, I'm taking that base model and saving it inside base variable. Now next step here will be to define a function, call it columns, table columns. So we're importing column, we're importing string, we'll have integer, we'll be using integer, and we'll also be using boolean. Now before we start creating our model, let me just quickly explain what are the columns that we'll be using in our database. Okay. So for our task database, for this project, we'll be creating a table called tasks. Okay. And this table will basically have three columns, which will be task ID and title, which will have our task title. And then we'll also have completed, which will be a Boolean value which defines is the task completed. Okay. So coming to here again, we are importing all of these data types from our SQLAlchemy library. Next step will be actually creating our model. Now I just explained that to create our model, we'll be using a base class from SQLAlchemy, and that base class is currently in database.py here, right? Let's import this here. So we'll say from dot database import base. We are importing this base class that we created here. Now, creating a model is basically like creating a class. So we'll say class, we'll call it task model. This is our model name, and to this we are passing our base class on top of which we'll be building our table. This table has first we will be defining our table name. So we'll say underscore underscore table name is equal to, or simply call it tasks. And then we provide the columns. So in our project, we have a column of task ID. Now, this is a column, right? So we say column, and this column has this data type, which is integer, right? And also on top of it, this column is also a primary key. So we'll say primary key is equal to true. This is how simple it is to create tables in SQLAlchemy using this class notation. Okay, so we have the task ID. Now next we create our next column, which is title, and this is also a column, and the data type for this is string. Okay, now we don't want this task title to be null, right? So this always needs to have some value. So for that we say nullable is false. You are telling SQLAlchemy here, this column should not be null. So nullable is false. And then we have completed. And this will be also a column, but in this we will passing a Boolean data type value. And here, by default, we'll say default value of this column is always false. So even though if you're not passing any values, by default, the value always is false. So whenever you're creating a new task here, by default, the task is not yet completed. We will fix it. We will mark it completed only after the task is completed. Okay. So this is how simple it is to create a model or to create a table using SQLAlchemy. We are importing our model. We are importing all the required data types, and we are importing our base model here. And on top of that base model, we are calling our model task model. passing our data table name on all the columns. So we have task ID column, which is integer and also a primary key. We have title column, which is a string, and then we have a completed column, which is a boolean. And default value for this is false. That's it. We have successfully created our model here. Okay. Now, we have created our model here, but that model has to be invoked here as well in our main.py file, because we are running this main.py file here, and this file is currently not attached to any of these files, right? So will we do one thing here? We'll say from dot models import whatever model that we just created, which is task model. We are importing that model, right? Now we have created our table. We have again defined our table here. This is not yet created in our database. We have just defined our table. We called it task, and we have defined all these columns, but it is still not created. Okay, to actually create that table, we use this line of code. We say base is equal to, no, not b is equal to base dot, and this base is coming from where? Database.py. Here we have our base. So for that, let's import that as well. So we say from dot database import. We'll import everything. We'll import base. We'll also import engine, which we created, and then also session local, which has our session. So here to create that table, to actually create that table, here we have just defined our table. To create that table, we say base dot metadata dot create all. And in this, we are passing our engine. Since engine is the one that is actually doing all of our operations, we are passing our engine saying bind equal to engine. So this line of code is actually creating our table here. Okay, in our main.py file. Now, to verify if the database is created or not, what we'll do is we'll run our server again here. Since we stopped it, we'll run our server again using the same command avcon app.main app / reload. Let's wait for the server to run. Okay, we do have an error. Let's see what the error is. Invalid URL. So looks like we gave a wrong URL here. And okay, so here we need to provide 3 slashes, not just 2 slashes. Yeah. Now, if you observe in our project folder, automatically we got a task.db file created. Okay. And this is an SQLite file. So this can be accessed using SQLite database manager management application. Okay. Now in VS Code, you have an extension called SQLite viewer. Let me show you. I already have it installed in my VS Code. So you have a extension called SQLite using which you can actually access your database. Okay. For that, you say open SQLite database, open database. And here it is asking us to choose our database, which is task.db, and it is automatically showing that. When I click on it, here if you observe, like how we have File Explorer, we also have SQLite Explorer, and automatically that SQLite Explorer currently has task.db, inside which we have task table created. And if I click on play button here, it shows our table. Now, since in our table we have no records, it is showing us a like empty table. Okay, but if you observe, we do have our task table created, and if you look at here, we have all the columns as well. We have task ID, title, and completed, which is our boolean value. Okay, so as soon as we ran our application, automatically SQLAlchemy using our engine created our database and also our table by using this line of code. Okay, now next what we do is, now comes validation. So until now, at the beginning, we also discussed about Pydantic, which we were using to actually validate our database. Okay. So we discussed that Pydantic has Pydantic schemas to validate data, and this data come from user or also whatever response we are sending. So response data. So to validate everything, we are using Pydantic schemas, right? Again, a schema is similar to a model, like how we have defined our database table and table column name and which data type the column should have. Similarly, we create schemas which also has variables and the data type those variables should only support. Okay. So now let's jump on to creating uh, Pydantic schemas here. For that, we'll create one more file here and we'll call it schemas.py. And here, let's start by creating our task schema. So basically, from our user, whatever file or input that we're receiving, that should always be a string, right? So we create a couple of schemas here to validate all the inputs and outputs. First thing we'll do is from import that Pydantic library. So from Pydantic import, we'll say base model. Again, this is also using a base model on which we are creating our schemas. And then first schema that we create is task create. To create our task, we are receiving a task from our front-end user. Receive task. So now what we are telling here is in Pydantic, whatever task we are receiving should have a variable called title, and the data type of this should be string str. Now this part of code is called as type checking. Python automatically supports type checking. So when you are defining any variable here, after that you can directly say colon and you can mention the data type that you are expecting for this variable. So now Pydantic automatically validates whenever you are passing this schema for any of your inputs. Pydantic will automatically validate if whatever input you have received has this title variable or not. On top of it, does that variable have only string data type? So it will allow only string data type. Let's create a few more schemas here. We'll also say task update. So this is for our update request. So task update will be, we'll have title which will be str string, and also since we are updating our task, we are also expecting the completed status which will be a boolean value. So bool. I'm creating another schema for our goal. So we are sending a request to AI, right? For that we are saying goal request, and for all of these we will be passing base model. For all of this we are passing base model that we have created here. We have imported here. Base model, base model, and base model. And here for goal, we are sending just a goal and which is str, string type. So we say goal, which is string, str. Finally, we create one more for response. So task base model, and then we say task. As a response, we are sending everything. We are sending our task ID, which will be integer. We are sending our title of the task, which is string, and for completed, it is boolean. These are all schemas that we'll be using for validating using Pydantic. Now, back to our main.py file. Now let's work on creating all the methods that we have, that all the various requests that we'll be using to perform our database operations. Okay. Starting with importing everything. Let's see if we have imported all the libraries or not. We do have FastAPI. We also need SQLAlchemy. So we say from SQLAlchemy.orm import session. To create our sessions, we'll be using this session module. And then we have already imported everything from database file. Now we have to import everything from schemas as well. So from dot schemas import. Let's import everything. So we'll say dot from dot import schemas and models. So from our models.py file and schemas.py file, we're importing everything into main.py here from dot import. Now let's start by defining our create task paths. Okay. For this again, we use a decorator which will be app.post. Now, reason why we are using post is because we are receiving a input from our user. From our input from our client, we are receiving something, right? For that, we are using post here. So app.post will give the path name as create task. Okay. So as we discussed, we will be creating all these paths for all of these tasks, right? Task for getting all the tasks. To create all our tasks, we'll be using create task. For deleting slash delete update. So all of these paths. Now we are creating those paths now in FastAPI. So here we have as declared our decorator, and then we are defining our function. We'll call it create task. Now this function runs every time you are getting a request of create task into FastAPI. In this, first thing we do is we take a input, task input, and this input is currently being validated. Now, when you are creating a task, you are receiving the task from user, right? So whatever task you are receiving from user is automatically coming into our method here, onto our function here. But this has to be validated with our whatever schema that we created here, because the user can only send a string as a title. User cannot send a number as a title, right? And for that, we have already created a schema which is task create. So what we'll do here is we'll say schemas, which is our file name, dot task create. Basically, we're passing our schema, Pydantic schema, and we are validating it with whatever input that we are receiving in this method create task into this URL. Okay. After that, we'll create our session by using our TB session. Now, whenever you're creating a session, we said that we need to use this method to create our session, which means whenever you're creating a session, that session is currently depending on this method. This method is what you use to create your session, right? So while creating session, you need to depend on this method. You need to use this method as well. So for that, what we do is we say here from FastAPI, we import a model called depends. And here we say whatever session we are creating is depending on our method, which is get db, which we need to import here. Get db. So whatever session we are creating here using db of session is depending on get db method. So now this function is taking our input, automatically creating our session, and now here we will run our database command, which will be creating a record. So we say that db task is equal to models dot. We are using our task model which we created for adding data to our table. Basically, we are telling Python, we are telling FastAPI, use this table, task model table, which we created here. Okay, and we'll run a query of we'll pass task here, title here, which we are receiving here from our input. So we say title is equal to task dot title. Task dot title. Everything we are receiving it in object format, and everything is now currently in this task. So from front end, we are basically receiving this object. From our client, we are receiving a task which has a string of task. Okay. So from this object, we are extracting our task here. So for that, we are saying task dot title. So we are extracting title from our task. Next line will say db dot add. Now, as we discussed, SQLAlchemy provides the default functions that we use to run queries into our SQL database. So this is the function. Add is the function that we use to create a record. Basically, this is your create record command. Create, not create, sorry, insert. So basically, this is your insert command here. So we are saying db of add. What am I adding? This task, whatever we received from front end here. So we say db of add, and we are adding a task here. After we added, we say db dot commit. We can commit our transaction, and then we say db dot refresh, just to refresh our database once after committing. Okay, and from this request, so when we are receiving a task, we are simply sending that task as a response. So we'll say return db task, whatever task we just added, we are simply sending the task as a response back. Now let's open this URL. Let's open this FastAPI application. And now the beauty about FastAPI is that FastAPI provides you automatic documentation. It provides you something called as a Swagger documentation. What I mean by this is in my URL. So when I am running my server using UVCon here, so when I'm running my server, UVCon is automatically running my server into a URL which is this one, right? And to this URL, if you simply add to this URL, if you simply add slash docs, FastAPI automatically creates a documentation for you. So it automatically basically creates a testing page for you, FastAPI, and that testing page will have all the paths that you have created. So I have a sanity path. If you remember, I have a function called sanity, which is basically checking our API if it is running or not, right? So if I click on this, try it out, I can execute this from here itself. See, you are getting a message called API is running. And then we also have create task. We created this path for adding a task. And if you observe here, if I'm clicking on try it out, since we are implementing schema validation using Pydantic, automatically it is asking for us a title, and also it is mentioning that we need to only provide string. So let me provide a task called task one. I'll simply call it task one and then click on execute. As a response, we are sending our task back. Whatever task is stored in our database, we are sending it back as a response. Right? Now here if you observe, we got our task one, which was created into our database as a response. And since it is a primary key, since our task ID is a primary key, automatically one got added. Automatically we're adding a ID here. And then we also have completed, which is defaulting to false. Okay. In our models, we will have one small correction, like addition here. We'll say auto increment is true. So whenever we are adding new fields here, automatically the ID becomes incremented 1, 2, 3, whatever task you're adding, automatically the number increases here. Okay. Now, let's look at our database. So we'll open this using SQLite here. And this time when I try to see all the tasks that we have in our database, if you observe here, task one, what we have shared from our client, right? from our Swagger application here, we tried to add a task one, and when we clicked on execute, we got this as an output. And the same task also got added to our database here. So what is happening is, whenever you are trying to execute that particular path, create task, whatever task we are sending is coming to our task variable here. We are validating it using our Pydantic schema. We are creating a database session. In that database session, we are creating in our table, which is task model, which is task table. We are adding our task. We are providing our title of the task, and then we are adding using db.add. We're committing our transaction. After that, we are sending the same record that we added as a output here. Okay. Similarly, we'll create paths for all the other scenarios, which will be let's create for deleting a task. So we'll say app dot delete, and this path will be slash delete. And for this, we'll pass a function called def delete tasks. Now, when you are deleting a task, you are expecting an ID to be shared, right? So from front end, user has to share an ID of the task that he is trying to delete. So we'll take that ID as an input here. Okay. And what we can do is we can also take that input here in the URL itself. So here we can pass task ID. What is happening here basically is your URL, you are expecting to for the task ID to come along with your URL. So when you are running that backend application here, this path should be slash delete slash also the task ID. So here we are expecting task ID to come as well, and that same task ID is now being stored in this variable, and this variable should always be integer. So we'll say int because ID is always int. Along with that, we are also creating our session. So same piece of code that we have here. We are creating our session using this getDB method. Okay. Now in this method, we are deleting our task, right? So for that we say first db task is equal to. So what we'll do here is first we will query into our database if we do have a task with that ID or not. Do we have a task with whatever ID we're receiving here? We'll query first. If we have a task, then we'll delete. If not, we'll send an error response saying task not found. Okay. So for that we'll say db task equal to db dot query. Here now we are querying here. With this we are passing our model. We are passing our table. So we are telling query inside this table, and the query is filter. This is basically like select and using where. This is filtering our records. To this we'll say whatever task ID we are receiving here. So uh, we'll say models dot from our table, task ID from our table should be equal to whatever task ID we are receiving from user. Okay. So whatever task ID we have in our table is should be equal to whatever task ID we are receiving from our user here. If we do have a task with that ID, we will get a response in this. So next we'll say if db task if not db task. Basically I'm checking if you don't have any task, then we'll say there is an exception, and it will be a http exception. So for that again here we'll use one more model, which is http exception. So using this model we can send a error response from FastAPI. So we'll say there is a http exception, and for the exception we need to provide two things, which is status code for not for. So we are using an exception of for not for status code, and the detail. So the message with this is task not found with the ID. If you don't find any task, we say task not found with that particular ID. Okay. If we do have a task, okay, we don't have any error here. Task, we found a task. Then we say db dot delete of that task, db task. We have deleted our task. After that, db dot commit. Done. And as a response, we are sending, we'll say message is task deleted successfully, and also we'll send our task which we deleted. We'll say task is db task. We deleted this task. Okay. Let's also add one more endpoint, and this will be for getting all the records. So we'll say slash task. For getting all the tasks, we'll be using this your path. So we'll say def get all tasks. And to this also, we are passing. So again, from user, we are not getting any input here. We are just user is just asking to send all the tasks. So we'll say we will create our session, db session. This is depending on get db method. Okay, and inside this we will simply query get all the tasks, send it as a response. So we'll say task is equal to db dot query into this table, which is models dot task model. So query from this table, we say all. Basically, you're getting all the tasks here. Okay. So we're asking Python to go to our table and query all the tasks. And whatever tasks we're getting here, we're simply sending that as a response. So we say return task. That's it. We're sending all the tasks as a response here. Now with this, let's test these endpoints if they are working or not. We'll go back to our Swagger UI here, which FastAPI is providing us by default. And in this now, if you observe, we have all those paths added as well. So we already had one task created, right? We'll see if we are getting those task or not by using this URL, which is slash task. What is this doing? This is getting us all the tasks that we have inside our database. Let's execute this. Yeah, we have one task inside our database, and we are getting that task as well. Let's do one thing. Let's create one more task here. We call it task 2. Execute. And this time, when I say get me all tasks, I got both the tasks now. And all of this is currently being stored in SQLite database. Okay. So we know that all of the endpoints are working. Let's try to delete a task as well. So it will ask for a task ID. Let's provide a ID which is not present. Now here we don't have a task with an ID of 3, right? And we are providing 3 ID here. What will happen if we are providing an ID which is not present? We should get an error response saying that task not found. Mm. Let's see what happened. So for delete task here, fine. Filter, what it does is it just gives us all that everything that we have with this filter. We are taking only the very first task here. Okay, we are telling SQLAlchemy get me only the very first match that we are getting from this filter. So this time now, I try to delete it. Yeah, I am getting a error saying that task not found with the ID. And it is a 404 error, not for code error. Now, since we have all the methods, all the requests that we have created, now let's jump on to actually creating our AI integration. Okay. Now, to integrate our AI model, we will be importing LangChain, which we just installed, which we installed at the beginning. So we'll say LangChain from LangChain, OpenAI, import, open, chat open AI. We are using this module for communicating with our AI models. And for this particular project, we will be using Mistral. Okay. Now, you need a API key from Hugging Face. Now, what is Hugging Face? Hugging Face is basically a repository of all the AI models that we have. Now, let me just open Hugging Face and show you. So if you open Hugging Face, basically what you'll find is all the different kinds of AI models that you can simply download and use. Or you can also use Hugging Face router to directly communicate with these models. You don't have to download them, you don't have to run them locally. You can use Hugging Face router, which we'll be using for this particular project, to directly communicate with any of these models. For our application, we are using Mistral 7B install, which is version 2. Okay. So what we are doing here is in this line, in this part of code right now, we are creating our route, which will be handling our AI integration. So we need to import a certain modules here. First thing we need to import chat OpenAI, and then we also need to import .env, import load env. We have to load all of our environment variables here. Okay. Now in environment variables, what I'm doing is I'm saving my Hugging Face API key. Now it is very important that whatever API keys that you're using, you are saving it in an environment variable separately. So NV create an environment variable here. I call it .env. In this, let me store my environment variable for Hugging Face, which is my API key. I'll call it Hugging Face Hub API token. And this is equal to my API token, which is this one. To use any of the Hugging Face models, you have to create this token first inside your Hugging Face login. You will get this token. We will be using that token to communicate with our AI models that we have in Hugging Face. Okay. Now here, let's create a function first, to which we'll be using to communicate with our AI model. Now, before we do that, we will initialize our AI model. Okay. So for that, here what we'll do is we'll say LLM is equal to chat OpenAI, and in this we'll pass a few things, which will be base URL, which will be uh, HTTPS router. We are using Hugging Face router for everything, right? For communicating with our AI model. So we are passing the URL for that router. So which will be router.huggingface.co/v1. And this we'll also pass our API key, which we have saved in our environment variable here. Okay. So for that we'll say API key is equal to os dot get env. Have we imported OS? No. Let's import OS. Yeah. So we say os dot get env, and here we are passing the name of the environment variable which we created, which is Hugging Face Hub API token. Okay. Fine. Next thing we need is we need to provide the model that we'll be using, name of the model, URL of the model, which will be Mistral AI slash. Again, you can get this link from Hugging Face. So if you go to Hugging Face here, here in Hugging Face, you have deploy button here, right, for this model. Not deploy, actually, you will be having another link, which will be we are using this one 7b v2. Yeah, use this model. When you click on this, it is it is giving us an option of using interface providers. We'll be using this, and here if you observe, you have a URL model URL, which is Mistral AI. This one. So just copy this, paste it in our model name here. Featherless AI. Okay. We are passing some few more things. We say temperature is equal to 0.7, and also max tokens. This is very important. Max tokens is equal to 200. Basically, whatever response we're receiving from our model, AI model, should have at most 200 tokens, should not use many more than 200 tokens here. Okay. So we have now basically like initiated our AI framework. So whatever LangChain framework that we have, we are now currently initializing that framework here using chat open AI. Okay. And next, let's create a function that is actually using that AI model to create a to pass a prompt. So we'll say generate task. We'll call it that function generate task, and this is a taking an input of a goal. We're passing a goal, which is a string. Okay, and here let's write a prompt. We'll write a simple prompt here. Okay, we'll say goal is whatever goal we have passed here. Goal is this, and I want you to break this goal, whereas basically writing a prompt here. Okay, break this goal into 5 actionable tasks and return only the task, one per line. I want my model to return only my task, nothing else, no extra things. Okay, and whatever response I am receiving, and now we have written our prompt. We also have initiated our AI model here using chat open AI. Okay, to actually send that prompt, we say LLM dot invoke. Invoke is the method used to actually send our prompt to our model. So here we have to pass our prompt. We are invoking our, we are passing our prompt here. And next, what we'll do is we say task is equal to line dot strip. Now, whatever response you are receiving here, we are from that response, we are stripping that response. It is sending us 5 tasks as a response, right? And every response will have enter. So it will have a line break. Basically, it will send us all the responses in this format. So it will send us 5 responses. So 5 tasks: 1, 2, 3, 4, and 5. Now what we are doing here is after every task we have a line break /n, right? So we are splitting all of our responses with /n and saving it inside a list in Python. So here we say line dot strip for line in response in our response dot content dot, we are splitting our content whatever we are receiving from our AI model based on /n. So we are splitting our content based on /n here. Only if we do have some content. So if this is line dot strip. Line dot strip for line in response dot content dot split, just splitting it based on /n if we do have a strip or not. So we already have all of our tasks in this, and now what we'll do is we'll say return. So whatever task we are receiving from AI, we are saying return those tasks here. So we are done with your function. Now we'll actually add an endpoint like this to access that function. So we say @app dot post. We'll call it task slash generate. For this path, we'll have a path of /task /generate, and we'll pass a function which is uh, let's call it generate task. Okay, and this is taking an input as well, which is goal. We are passing our goal, and then from that goal, we are receiving all the tasks, right? And we also have defined a schema for this goal. So we'll validate it using that schema. So we say schemas dot goal request, and we are creating a DB session, same like how we did for all the other paths here. Session, and this is depending on get DB. Inside this, what we do is we say task is equal to whatever method we created here, generate task. We will use this method. So we say task is equal to generate task, and to this we are passing our goal. Now, whatever task we have received here, we will one by one, line by line, add all those tasks to our database. So for that, we say for task in all of the tasks that we received here. For all the tasks, what to do is clean those tasks first. So we are extracting our title here, which is task dot. We are stripping all the, if we have any spaces, or sometimes AI model can also give us task with all the numbering. We don't want the numbering, right? We only want our task. So we strip all of that. We say task dot left strip. Strip all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and also dots and also dashes. Strip everything. Dot strip. If it is not cleaned, so if we don't receive any title, we don't receive any title, or if the length of the title is less than 3. We won't add any task here. We say continue. So what we are doing here is we are checking if we have received any task. From that task, we are stripping all the numbering and everything from the. If we have if we have a task, proper task which is more than 3 characters, then we are adding. If not, we are continuing. We are just moving on to next task. So here, once we have a clean task, now we say db task, like how we used for creating a task, right? So we say db task models dot task model. We are using our task model here, okay, and then we say title is equal to our clean title, which we have stripped everything, and then we say db dot add our db task, and then commit db dot commit. At the end, we also do a db refresh. db refresh of db task. So we are looping through all the tasks that AI has given to us, and we are adding all of those tasks line by line into our database. Okay. At the end, we say return all of our tasks. Append db task. So whatever task we are receiving here, we are appending it to another list called created task, and we are sharing that list as a response here. Created task. Now let's try to finally like execute this path and see if we're actually uh, like connecting to our AI model and getting our task or not from our AI model, which was Mistral. This model, right? Mistral, this one. Let's go back to our API endpoint. Let's refresh this. And now we should have another endpoint that is task.generate. Okay. Now here I pass a goal called learn. Let me pass a goal here, which will be learn fast API. Now, when I click on execute, I should be executing that particular generate task function, which is giving us a task from our AI model. And whatever task AI model is giving, we are returning that those all those tasks. Let's see if it works or not. Great. If you look here, we did get a task, but the problem here is that AI model is also giving us a lot of blank data. This happens sometimes. This is very common when you're using AI models. Okay. Now let's try to execute again. This time we got more tasks added. Now, if we try to get all of our tasks using this link, if you observe here, see when you gave a goal of learn fast API, what that AI model did is based on that goal, it gave us 5 tasks here, which is familiarize yourself with fast API, set up a new fast API project, endpoint with fast API, implement. So it gave us 5 tasks basically that we can use to complete that goal. And each and every time it is giving us 5 tasks. And everything is automatically also being added into our database because we are using this part of code. We are saying to our database, add the DB task and also commit. Okay. So guys, this was a like a simple project that we built using LangChain, and also how if you observe here, we took a model from Hugging Face, and we tried to use that model into our LangChain, okay, uh, and try to get some tasks from that AI model, right? Uh, those who are seeing the session, like we'll be having few more workshops like this. So as we could not, again, it's a 2-hour workshop. in 2 hours it is difficult to cover everything. So we just went into and hands-on learning where we try to build an application, a simple, very simple application that try to cover all the topics. Okay. So finally, again, for this workshop we covered like all these things which were FastAPI. So we understood what is FastAPI. It is a Python framework, modern framework, which we use to build APIs, which we use to build backend. And then we understood what is Pydantic, which is a validation layer. In that we have schemas, Pydantic schemas, using which we are validating our data. We have SQLAlchemy, which is acting like a translator between our Python and database, which is SQLite. And LangChain is a framework in which we have certain methods that we use to actually communicate with our AI models. And those AI models are currently being provided by Hugging Face. Okay. And in this single file, you are able to connect to an AI model using LangChain here, which has a chat OpenAI. Using this, you are able to connect to your AI model, which is currently being provided by Hugging Face router. And in that model, you are sending a prompt in this method. So you are taking a prompt, you are telling send me only the task as a response, and you are actually setting that prompt using invoke. So you are sending that prompt, you are stripping that response into multiple lines here based on slash n. Okay. And whatever task it is giving us, we are storing everything into our database here in this section, right? And for all of this we are using SQLite as a database. So this was about how to build a say, like basic fast API application using LangChain and using SQLite as database, and to create a basically a code-based task generator. If you have any questions, I'll just wait for a few minutes. I'll just wait for 5 minutes. If not, we'll close our work session for today. Again, at the end of this workshop, I'll let me just in chat. I'm pasting all of the resources for this. Okay. So let me just yeah, guys. So I'll paste all the resources for this workshop that we have in this workshop in the chat. Meanwhile, if you have any questions, please ping in chat for this workshop. You can just simply download that repository as a zip file and install all of your dependencies, all of your libraries. You will have a requirement.txt file in that, and then simply run your project using UVCom, and you'll be able to get all of this. But you definitely need to use your own Hugging Face and Hugging Face API key token. Okay, so for that, create your own environment variable and add your own token in that. Now, coming to let me also share. Let me also share you. A simple document which you can blindly follow to create this project. Okay, so I'll just share you a document. It will have everything like in detail about what we did in this project, right? Let me just. So this is a document. Uh, in this document, you have in detail what are the technologies that we use in the workshop. It will also have all the code and all the explanation for that code as well. So basically, it's like a summary of it's like a compilation of this 2 hour workshop. You will have all the resources in that document as well. And also, let me share one PPT as well, which will be briefly showing you. Have a brief on whatever we discussed in this workshop, all the tools that we are using, all the technologies, and coming to another document, another Google Drive document. In that, you will have all the details about this workshop, a small explanation on all the technologies, and also the code and everything. Okay. With this, thank you guys for like going on this journey with me. In 2 hours, we tried to cover everything, and we will be having more workshops like this. And if you are interested in learning more about FastAPI, learning more about how to integrate AI into our projects using LangChain and all, you can again contact any of your project managers or your managers, and they will inform you about the next workshops and everything. Okay. Thank you again for joining. With this, we are closing our call. Thank you, guys. So, bye.